Hello, and welcome to another episode of Hacking with Friends. Today, I have my friend Stefan on again to show us a little bit about a new microcontroller we haven't covered so far, the ESP32, and we're going to talk a little bit about one of his programs, which is able to sniff wireless traffic using this very inexpensive microcontroller. Stefan, thank you for being on again.
Hello.
So, can you tell us a little bit of your background in working with the ESP32 and what makes it different from the previous chip we were working with, the ESP8266?
Yeah, so the project we are going to look at today is the Arduino PCAP library. I think that might be the first project I developed with the ESP32. I'm not actually sure, but yeah, we will get into that just in a bit. The difference is the ESP32 is basically the successor of the 8266. It's more powerful, it has 2 cores, it's clocked higher, it has a lot more RAM. It's also a bit more expensive, but yeah, it's just like a more powerful chip, and it can also do Bluetooth and yeah, some other fancy features they added in the software. For us, the main difference is that the 8266, we can use that for packet injection, and with a little trick we can inject any kind of packets. Meanwhile, the ESP32 cannot do that. There is a packet injection function they provided, but it's blocking stuff like deauthentication packets, for example. So you can only send a certain types of packets. I think you can send any kind of data packet and only like beacon or something, but all other management frames are blocked. As they are on the new software SDK for the 8266 as well. But again, for the 8266, we can basically hack that. So that's why the deauthor is using the old chip, and it's not compatible with the ESP32, which is the new chip. But the 32, because it has so much more power, so much more CPU and RAM, we can actually use it to sniff traffic much, much better. Just because, we have more memory to buffer it, we have more processing power to filter it, and so on. And that's where this project comes in.
So for anyone who's just getting started with microcontrollers, this all might be a little bit confusing, but when we're talking about, more expensive, that means that, the microcontroller I'm holding, which is a ESP32 development board that's quite small, costs about $5, as opposed to maybe $2 for an ESP8266. So when we're talking about expensive, we're talking in pretty relative terms, because this is still even, half as expensive as the cheapest Raspberry Pi. And that's not including all the accessories you would need to actually work with that device. So this doesn't need a micro SD card in order to get started on it. It's a pretty powerful little device for about $5. But what's interesting is a lot of people who are getting into this don't understand the difference between these two chips, and they expect that because this one's more powerful, it can automatically do more stuff. And as you just explained, that's not necessarily true. In reality, this one actually comes with more restrictions because it's newer, and there's, correct me if I'm wrong, but we can't just go back into an old SDK and just send arbitrary packets with this one. So it's just not possible to, with the same amount of work, be able to send the same kind of packets we can send with the ESP8266.
Yeah, exactly.
So the benefit obviously is you have a lot more to work with. This has, just more kind of power behind it, but you'll see applications for the ESP32 like strapping a small camera onto it and having like a camera module like the ESP32 cam. And you don't really see a lot of ESP8266 camera projects, or at least I haven't seen a ton of them, just because you have to really have like an ESP32 to get good quality video. And on the ESP32 cam modules I've seen, it even has the extra horsepower left over to be able to do things like facial recognition and facial detection, which is pretty awesome to have all that power in such a small chip. So there's a lot more potential in this bigger, more powerful ESP32, but we also don't get total freedom. So, when you're looking at getting started on one of these, you might be one of those people who wants to get, the slightly more expensive but better product. In this case, it actually means that it's going to be less effective for some of the things you might want to do, like deauthing or having an influence on wireless networks. But if you are looking to sniff, maybe you've been considering getting a wireless network adapter, you want to do packet sniffing, and you might even want to try to like grab a handshake and crack it, something like that. that's where this actually gets kind of interesting. And Stefan and I have been discussing whether or not it's possible to use this super cheap ESP32 to be able to grab a Wi-Fi handshake and actually crack it. So I think we might actually try to do that today. I have no idea if it's going to work or not because I don't think we've tested this. But either way, we're going to do some sniffing with the ESP32 and see if it's possible to, maybe on a computer that isn't capable of running, or that doesn't have a wireless network adapter that's capable of monitor mode, if we can use this to do things like detect when a device is nearby or see what kind of encryption a nearby wireless network has. Do you think that's probably something we can expect to do?
Yeah, absolutely.
Cool.
We have to try out how well it works. I think we might have tested this. It's just been a long, long time.
Yeah. Yeah, I know I've been really curious about whether or not this would work. So, okay. All right. If what's interesting about this as well is that the same project works on the ESP8266 and it also works on the ESP32. But maybe you can explain what the difference is between how effective it is on each platform.
Sure, yeah. Basically, as we said, the ESP32 has more power, so it's better for getting more packets, basically, because the ESP, it's easier to lose packets on the 8266 because of the limited memory, and there could be a lot of packets floating around in the air. You might lose some. That's probably what we are going to see today as well. We have to see if we can filter it or something to get the results we need. On the other hand, you, Kody, live in a remote location now, so I guess it's less of a problem than it is for me, for example. But basically, we have to put the traffic through a USB cable, and that's over serial, and that has a very limited throughput. So yeah. Because the ESP32 has more RAM, we can better filter and buffer packets. That's one thing. The other thing is that the 8266 has a packet sniffer built in, but they crippled it. I can't exactly tell you why. My guess is that it's a power issue, that the CPU isn't fast enough or something. But the packet sniffer they implemented limit you to, I think, like 100, 150 or something bytes per packet. So if you are getting a packet that is longer, if it receives a packet that is much longer, then it's just going to get cut off at a certain byte. So you can still sniff and, for example, see beacon frames. So you could still see then the network name and what kind of encryption it uses and that sort of things. But more, for example, if you want to sniff data packets, then this becomes pretty ineffective because those are usually encrypted if it's a WPA network. And because you're missing parts of the packet, you can not even decrypt it if you have the key. So, yeah.
Now, that doesn't mean it's totally useless, though, because I know that you've built a couple projects based off of this ability, and it seems like you're still able to detect maybe problematic packets like a deauthentication packet, which gives rise to the deauth detector, which is a ESP8266 based project that just sniffs for deauthentication frames, or does it look for disassociation frames as well? No, I added that. I think I forked it and just added that one thing. But yeah, so there's a version that looks for basically packets that are indicative of someone using one of the most common wireless tools to kick other people off the network, and is able to determine whether or not someone in the area is sending those packets off. So even though we're not able to see the full length of packets, we can't do things like capture a handshake or do more meaningful sniffing. We can still do things like just detect maybe malicious packets in an area and do some basic detection of, for example, the MAC address of a device that's sending something. So we could tell when a device is nearby, even if we couldn't see the full length of the packet it was sending, right?
Yeah, so again, you can only see a certain part, like the first 100 whatever bytes of the packet. So analyzing the packet contents might be a bit limited because, again, data packets, that's kind of, you can't really do much with that. But you can still analyze management packet data, but you can still analyze the entire metadata of all packets around you. You can count how many, you can analyze how many of what type. You can still see who is sending data to who, because you have the MAC address header, which tells you the sender and the recipient. So you can still see who is connected to which network, who is communicating at what point of time, and how much. And through that packet patterns, essentially, you could still determine if you would build a more complicated system, you could still determine whether or not someone is using a specific application. For example, if someone is watching a video or just like casually browsing the web, would create a very different packet pattern. And that's sort of the stuff that you can see even without looking inside of the packets, just through the metadata. So yeah, very powerful stuff.
A good way to think of it then is, the ESP8266, even with its crippled sniffer, is able to do metadata analysis on nearby Wi-Fi packets. So the packets may be cut off, but we can see who's sending them. We can see the relationships between devices and a network in an area. We can see devices that might be unassociated or not connected to a network yet. And we can determine what channel all of these devices are broadcasting on. So we could then zero in on any particular ones and then make observations about things like data usage, or maybe which devices on a certain channel are more in use or present at a particular time. So again, like, it's not nothing for sure. There's lots of different applications for this, but a lot of people also want more information. They want to be able to analyze the packets in something like Wireshark. And that's where this project is really cool, because as we'll try to show off today, you can actually use this in Wireshark and have live results coming in from a microcontroller over a USB cable. And I think that that's really cool.
Yeah, so we are going to try to catch a handshake, four-way handshake. And for that, we need the ESP32, because you could still capture a handshake with the 8266, but it will be cut off, so you cannot try to crack the password with that. That's what you usually do if you capture a handshake. You would try to crack the Wi-Fi password. You could still receive it on the old chip, but you wouldn't be able to do much with it. So that's why we are using the ESP32. And yeah, let's just try out if we can get this working.
Cool. Sounds good. All right. So I'm going to go ahead and share my screen so you can see it. Hopefully it works well.
I will also try to follow along. I have my system here pretty much, a clean system. We'll see how well this works. The project is very old, as you can see, 3 years ago. Yeah.
3 years ago. Cool. So anybody who wants to follow along with this, you can go ahead and check out github.com/spacehoop, which means space chicken, and /Arduino PCAP. So I at least like to teach people a little bit of German if we're all going to be here doing this. So a library for creating and sending PCAP files for Wireshark and other programs. So Wireshark is that how you spell programs? That's fine. Is it
huh? Programs? Is
that how you spell programs?
Something wrong?
I'm sorry. I shouldn't.
Oh, 2 M's.
No, it's fine.
Yeah,
it's
sorry.
Yeah.
It's 3 years old.
Bug fixing. Just a little bit of bug fixing. Okay, I guess back then we used 2 M's. Sorry. So as you can see, what this is designed to do is interface with more powerful programs that are designed to do packet analysis, so that even though we're not going to be passing maybe like capture filters or something over to the ESP32, which by the way would be an awesome feature, we can still have all those packets go to a program that is able to read them. And there's a little Python companion program that's included in this that is really helpful and cool. So you can see you can go and download the entire zip folder. You'll need information on installing Arduino IDE libraries, which is actually pretty straightforward. You just put it in the libraries folder. That's about as hard as it is. And then for dependencies, we'll need the Arduino time library, the ESP8266, and the ESP32, obviously, because we're using those. And then we're going to be using the serial shark example, so we'll need Python 3 installed on our computer, PySerial, which is a dependency we can just install via pip, and then Wireshark, which I have installed. Any notes on that, Stefan, or anything people should keep in mind when
not sure.
those?
Let's find out.
Okay, cool. So there is some mention of using SD cards here as well. I'm using a module that doesn't have an SD card. So, One thing I thought of is you could also use like something like an ESP32 cam that has a module built in and just has a camera attached to it for no reason then. But, you know, whatever. For now, I'm just not going to mess with the SD card library. It says, yeah, so it says if you don't use an ESP32, you will need the SD FAT library, and I am not going to be using the ESP3266,
Yeah, exactly.
so that means I probably do not need that. Serial Shark script doesn't work on Windows. What's up with this?
Yeah, there were some problems with that. And again, this is 3 years old. I'm not sure.
It's okay. It's just funny that, you know, it works on Mac OS, which is your most hated system, but it doesn't work on Windows, which, you know, most people use. But that's fine. All right. We'll go ahead and check on the settings, where you can see here. So this is to set the channel to sniff on a particular channel, but is there the ability to skip it to, oh, channel hopping, right? Okay. If channel hopping is true, then it'll scan on all channels. So for someone who's getting started with this, then you could just kind of set this up to either scan on a single channel by setting this to false, or you could set it up to scan on all channels by setting it to true. So it kind of depends on if you already know where your target is, in terms of like what channel they're on, right? Yeah, so as wireless people know, anytime that you're scanning on a different channel, like if you're doing channel hopping, it means you're not scanning on the channel where some action might be happening. So if you have channel hopping set to true, odds are you're probably going to be missing a bunch of packets from maybe the device you're interested in, because the radio is going to be on a different channel most of the time, actually. So it's only going to pick up packets that are there when it happens to be listening. So if we do happen to know, maybe after the first scan, what channel our target is on, it's really worth our while to disable channel hopping and just zero in on the channel where our target is
exactly.
operating.
Otherwise, we have just too many packets and we'll probably lose what we are looking for.
Yep. And you can see also that you've very nicely given us the ability to change the hop interval. So if we are really concerned about that, we can make it longer or shorter to either, you know, be on a bunch of different channels all the time, or maybe spend a little bit more time on each channel to get a more representative count of the devices that are actually operating on that channel. Because we'll miss a lot of stuff if this interval is very short. Cool, and then we're going to be attempting the live capture via Wireshark. Can you tell me what we need to do in order to get that working?
Well, you need to have Python installed. You need to have the ESP flashed with the code. There are different examples in the library, and then we just start the Python script.
Cool. Okay, let's do it. And it's Python. Yeah, it's Python 3. Okay, good.
Yeah.
Saving to an SD card. So I don't have one. We're going to skip this. But if you're interested in this stuff, you could create a little sniffer that actually saves to an SD card, and then you could go back and pick it up later. So we're going to be doing an example where we're analyzing it live today, but this has the potential to, you know, basically, I was explaining on an idea where you could have this as like a private investigator, place it near like a subject's, I guess, place of residence, and then just come back and pick it up later. And it would basically tell you when that person's device had appeared or disappeared, what network they were using, what devices they were using, and basically get evidence of, like, you know, signs of life from just wireless signals, which is a pretty sneaky way of determining whether or not someone has been home, or I guess the history of them being home over a relatively long period of time. So I don't know. I think there's lots of different ways you could use this project. Some of them creepy, but some of them useful for people that conduct investigations or otherwise, you know, are responsible for determining like whether or not someone is home, or what the pattern of that has been. But yeah, I don't have an SD card though, so it doesn't matter. So one thing I'm going to have to grab actually is I need a dongle, or in this case just a USB Type-C to micro USB cable adapter, which I'm going to grab from my production assistant, just because, thank you, I'm using a MacBook Pro and it's got nothing but USB Type-C. All right, so here I'm using a oh my god, in Arduino it's called like a D1 Mini ESP32 or something. It's basically just like a very small outline for an ESP32 chip that I think is really handy until you have to solder it, and then it is terrible because all the pins are very close together and there are a lot of them. But I really like this chip. I've bought like 50 of them. So for an upcoming class I plan on
Oh,
doing.
boy.
So yes, I have a lot of these, and they are pretty easy to work with if you're looking for suggestions on an ESP32 board to get started with. Stefan, what would you recommend for an ESP32 board if someone was just getting started with them? I know we have a lot of opinions about ESP8266s, and we prefer the D1 Mini or the Node MCU, but I've heard a lot less information about what would be a good ESP32 board for beginners to get started with.
There are different Node MCU like ESP32 versions, like the one you see there on the YouTube preview thumbnail.
I bought one of these from that electronics store in Munich when I was in Germany, and it was like $15 or $20, and it was terrible.
Okay.
The ESP32 module fell off of it. So but this is also the most common one that I see as well. It's like, if you're just going to an electronics store or looking on Amazon or something, you find a lot of these.
Otherwise, this one, I don't know if you can see me, Kody, but this is from Espressif. I really like it. It's the ESP32 Pico kit. As you can see, it doesn't have like fancy metal shielding because it's using a different chip. I mean, it's still the ESP32, but yeah, let's not get into the details. Basically, this is a smaller version. Yeah, Pico kit.
I'm pulling it up on my screen.
I really like it because it's very thin, so you have no problems fitting it on a breadboard.
Is the one that I have on my screen, is this it?
Yeah.
Oh, cool. Looks like it has one of those nice 3D antennas as well.
Yeah. It's very high quality. Again, this is from Espressif itself. I think they are selling it for like $10, $15.
Whereas on AliExpress, I'm currently buying mine for $5.
Yeah. I mean, maybe you can get this cheaper on Ali as well. Probably under 10, I would imagine.
Yeah, so if you want to see the one I'm working with, it's this, $388. Oh my God.
Yeah.
How is that even possible? But then again, usually you click on this and it's like, pick a different color, and then the price goes up by a bunch. But yeah, so as you can see, there's versions of this that are quite cheap, and if you are looking to get started with, it seems to just be $3.88. Yeah, so $4 for an ESP32 module that works perfectly fine. But again, these pins are very tiny and close together. One thing I will mention also is we're not going to touch on this today, but it is totally possible to do Bluetooth stuff with these, and they also support MicroPython. So there's lots of reasons to maybe pick one of these up if you've been considering it. Because if you like Python and you want to start developing on a microcontroller, MicroPython is a lot of fun, and I like it a lot. And also, if you want to, just get started writing Bluetooth applications or make like a little Bluetooth boat or something, which is something I'm going to try to do, then you should just go ahead and do that. So there's no releases, so I can't just flash this over the lazy way. So I'm going to do it the way that I'm supposed to do it. Actually, I could just download the zip, I guess. Huh.
Yes.
I'll just do that.
You have to.
I don't have to. I can
You
get
have
Comet.
to.
All right. So we're probably going to have to go. So we're probably going to go then. Oh my God. Sorry. Wow, there's so much stuff.
While you have been talking, I'm also installing all the stuff required, and oh boy.
Let's see. So
again, this is a 3-year-old quick proof of concept. I feel a bit ashamed because it's so complicated, and I could have made it so much better.
Okay. I'm gonna go back and find out where that downloaded to. Although I'm a little afraid to. Where is it? Arduino PCAP Master. Okay, cool. Oh, and pictures of that clown hotel. Great.
By the way, you also need to download this time library if you don't have it already in Arduino.
Okay. All right. So here we have Arduino PCAP Master, and this is. Can I just get rid of the dash master and then just drop that into my Arduino library?
Yeah. You can also
Okay, cool.
keep the dash master.
Well, it just seems like a little pretentious, to have the master at the end of it. Because like, you're pretty good at this, but I would say you're the master, Stefan. So I'm gonna go ahead and go to, oh my god, Arduino, which is in my documents folder. Why? All right, and it's not alphabetical, so that's great. Hold on. Arduino, here we go.
It doesn't look
Beautiful.
better on my end. Oh, hey, but
Yeah.
I finally got it to compile.
So then I'm gonna go in this big mess and find the ESP32 deauthor master. Man, you're into just masters, huh?
It's not me, it's GitHub.
I'm sure.
Yeah, it's the master
So
branch.
now I'm gonna have to.
You know what I should
create it
do?
again.
I should change the you can set a new master branch, and you can name it however you want. And I should just call it Meister, which is like the German version.
Meister would be so much better. Okay, so the ESP32, I found it. So now the last step is I have to drag this and drop this into the library folder, correct?
Yeah.
Which for some reason looks like exactly every other folder in this entire. Why? Sorry, macOS is really.
You should
His name.
rework your file structure.
I just have a lot of files because I do a lot of stuff, Stefan.
I can see.
So I need to find the library.
Okay.
All right, so this is usually a pretty simple process. Libraries, oh my god. So basically you just download that zip file, you unzip it, and then you drop it in the library folder. And then when you start Arduino, this thing should already be in there. So if I were to go to the libraries, oh my god, I'm so scared. Include library. If I go to, what is it, like the custom libraries? Or is it just contributed libraries? Where would I find it fastest?
What are you trying to do?
I'm trying to find the library in Arduino, yeah.
I tried to find it over the library manager, but I couldn't, so I just downloaded it from the GitHub.
No, not the time library, the one that we just put in the folder.
Oh, you don't have to include it, you just open an example. So go to File, Examples.
Oh, but first I should select the ESP32 chip, right?
Yeah.
Okay, so the one that I have already, but if you haven't done this already, then you have to go into Arduino, Preferences, and then since we're dealing with a totally new microcontroller here, we have to go to the additional board manager URL, and you can see how important Stefan and I are by how many JSON sources we have defined here. But in actual fact, this is terrible and is very annoying because I get hit with a bunch of errors all the time. But this last one right here is for the ESP32. It'll give you access to all the different boards that the ESP32 has to offer and all the different iterations of it. You can go to then Tools, and when it eventually loads, we can go to our board manager and select an ESP32. Oh, basically, we'll install the ESP32 boards, and then from that, we can select which one we have. And this is pretty important. I'll go to the board manager, because if you don't select the correct board, it will not work. When I flashed this to the wrong board, I got a brownout warning every time I try to use it. So it's really important to select the right one. So as soon as this finishes downloading, then I can type in ESP32. And this is the package you guys need to have installed in order for these boards to show up in Arduino. You'll be super confused as to why they're not showing up if you don't have this. So once it's installed, you can go ahead and in Tools, when it again eventually opens, select the correct version of the ESP32 chip, and it should even auto-select the port. But if it doesn't, then you can just locate the serial port and then put it in there in a minute. So I'll just make sure that this is actually, oh my gosh, this takes such a long time. I don't know why this is instant in Linux, but in Mac OS, I get this pinwheel every time I click on Tools. It's very distressing. But I guess a lot of work is going on behind the scenes. I just don't know about what. Great. There we go. Wow, that was dramatic. So I've selected the Wemos D1 Mini ESP32. But if I go down to the ESP32 boards, look at how many of them there are. There are so many that are supported. There we go. Mine is like the third to last out of all of these. So there's lots of different ESP32 boards you can use for this project. I just like this one because it's small and has a lot of pin options. We have all this other stuff set. So now I should be able to go over to examples, and this should pre-populate some stuff with just examples for the ESP32. So examples for the Wemos D1 Mini ESP32. That's kind of what I want to pay attention to, because these are things that are going to be compatible. And I can also see the custom libraries that are down below too. So
have you restarted Arduino since you dropped the library folder?
No, I haven't, but I also think I already had it. But either way, I'll close this.
Because I didn't see Arduino PCAP there. That's
Let me
what
try
I'm
again.
asking.
All right.
While you were doing that, I'm trying to fix a Python script so it works on Windows.
Oh, good. That would be a great outcome if we could get that working too.
It's so weird.
Oh my god.
Yeah, Stack Overflow to the rescue. So
once this incredibly slow restart process opens up again, then I'm just going to do exactly what I was doing before. Go to examples, ESP32. I didn't see Arduino PCAP either, but maybe it's in the custom libraries. Adafruit, Arduino PCAP, here it is.
Sneaky. So you
Yeah,
want
so
to open...
it didn't show up under those.
You want to open ESP32 PCAP serial.
Right.
Because we are using the ESP32 and we're using the PCAP library and we want to use it over serial.
Cool. So here we can see the settings. It's set to channel 1, baud rate 921600, channel hopping true, max channel 11, hop interval 214. Anything to change here?
If you like, otherwise we can keep it at default. Yeah, channel. So it goes from channel 1 to 11. Yeah, it should be good.
Okay, cool. All right. I am afraid to click on tools, so I'm just gonna compile and upload it and hope it works. One difference I noticed between the ESP8266 and the ESP32 is that when you're flashing to it, the ESP8266 like lights up and flashes and lets you know that data is being written to it, and the ESP32 just sits there with its red light doing nothing, which is weird to me. It doesn't give me any like feedback that it's being written to. But I'll take it on faith that this is successfully compiling and writing. So I guess we'll see also if I made any mistakes when it comes to making sure I have the Arduino time library and all the other stuff ready. So nope, it compiled. Cool. It looks like it's flashing.
So you had the time library already installed?
Yes, I did.
Okay.
I sure did.
So we should mention to the viewers that basically the process you did for adding the PCAP library, you have to do the same thing to add the...
Include library?
No.
Libraries?
I mean, maybe. I couldn't find it.
That's how I do it. Wait, it's Arduino time?
Try it. Maybe you can find it.
Yeah. Where would you find it if not through the library manager?
On the GitHub README of my PCAP library, there is a link that links you to the original library GitHub, and there you can just download the zip as you downloaded the PCAP zip.
Is it Arduino time all one word?
I have no idea. It's just like time library. But yeah.
Yeah. I'm not sure about it. Okay, so then that's weird. But in order to have this other library that you need, then we would go over to your GitHub and do what? Where is it? Arduino time library for all examples.
Yeah. Yeah. No
weird.
Good.
Arduino Sleepy Dog library. That's inconvenient. Okay, so that's very annoying. So in order to get this to work, then you have another step that you have to do. You should... is this actively updated? Oh, 2 months. Yeah, it is. It's more
20
updated.
Days.
Yeah, that sucks.
It's just called
so
Arduino time library. It's a bit... Bad naming.
I don't like it. So you can go ahead and clone or download this, do the zip file, and then just do the exact same thing. Drop it in the library folder, and then you have this dumb time library that I don't like because of the way it's named. It's just timelib. Can you just name your stuff in a way we can find through the GUI?
Yeah, maybe it's not in a library.
You're frightening
manager.
away all the noobs. Okay, well I hate it and it's gone. But anyway,
I mean,
we need to have that Arduino library in order for this to work. So there's two Arduino libraries here. There's the PCAP one, and then there's also the time library, which we'll need. Sorry for not mentioning that, but Stefan, you should put this inside so that it's all one folder. But I guess then when this one gets updated, it wouldn't work. But anyway, all right. So I'm going to press Command-Shift-M, and let's see what the heck happens. 115200 baud gets us a bunch of hot nonsense. What baud rate should I be using?
The 900 whatever it is.
900 whatever it is
Yeah.
will be exactly what it is.
Yeah.
I don't think I'm moving in the wrong direction.
It's not available in there.
Oh, fun. Okay, so
Yeah.
we have a baud rate that we can't see in the serial
Well,
monitor. But
you won't be able to see much anyway. It's
Okay.
It's transferring raw data, so it will be similar to what you're seeing now.
okay, but if I see this, and it's not just saying, that it's crashed, basically, then at least we've got something going on.
Yeah.
Okay, cool. All right, so this tentatively worked.
Yeah. It looking
All right,
good.
so what is the next step then?
Well, it's working. We have it flashed and we have it connected. So we just have to start the script, which is in the library folder under extras. There's a little Python script we want to start.
Okay, this is not in any order I can discern. Oh, date modified. That's even less helpful. Sort by name. No. Oh, God. Or Arduino PCAP master. There we go. So extras, and here's serialshark.py. What do we need in order to have this program work?
We need Python 3, and
Yep,
I
got it.
think we need the serial.py module.
Serial.py module. So how? Let me go over here.
Pip
to
install serial.py.
Okay. Pip 3.
Sometimes it's pip, sometimes it's pip3. Python
Okay.
is very
Pi serial.
surprising. Oh, Pi serial, not serial pi.
Yeah. Good thing I checked, huh? But then again, you also wrote that thing I just checked, so you were right either way. Permission denied. Let me
Sudo.
I can just try. Yeah, I was gonna sudo it, even though you're not supposed to, but I'm gonna do it anyway because sometimes it's fun to do bad stuff. Boom. Pi serial
Yay.
installed.
So
Okay.
I
And only
found a
some yellow, which is less serious than red for anyone who's just getting started with computer science.
I found a supposedly a fix on Stack Overflow for the Windows problem, but yeah, it's just not working.
All right, well, over here, I'm on a Mac, which I know you hate, but I'm pretty much ready to go with the existing project. I've located the serial port that I'm connected to, and I'm ready to run this Python script. Is there anything else I gotta do? What do I gotta do?
You just start the Python script, yeah.
Sir, how do I hack? Okay, so I'm gonna just believe you and just start the Python script. Is it gonna is it interactive? Is it gonna ask me for the serial port it's connected to? Or is it just
I hope so,
magically
yeah,
find
it should
out?
be.
All right, Python 3, all right.
All right. He doesn't believe
Go.
me.
No, I don't. Okay, yeah, it's gonna select the serial port.
All right.
I'm gonna
You
give it
need
the
to
right one.
you need to give it the right one.
Select a baud rate. I don't care, right? Just default.
Yeah.
Enter.
We
Select the
didn't
file
change it.
name. Space. Do I need to add .cap or will it do that, or .pcap?
You need
Or will
to
I make
edit.
spaceune.pcap.pcap?
No,
Okay.
edit.
Spaceune.pcap?
Yeah.
Serial connected. Firing. All right.
Whoa. Okay, look, go in the folder and see if there's a file.
Okay. Where is it saved? Oh, right. It's gonna save it in whatever directory I started running this in, right? But it didn't though.
Oh shit! Where did you?
Oh wait, no. Yeah, sorry.
Where's your console?
I'm in my
terminal.
friggin' root. I'm in my root directory.
Shit.
Lame. Okay, here we go. I see it.
COVID.txt.
Yeah, don't worry about that file. Stop reading my files. All right, I'm just gonna open this.
It has a virus. It's a virus file.
I mean, I had to pick a name. It seemed appropriate. All right, so we got. I'm opening this, and it's like finding local interfaces, but I'm not going to select any local interfaces because my local interface is actually this dumb little chip, huh? But it's.
Oh no.
Oh no.
Oh no. How big is the file?
That's a great question. The file is exactly
I have the same problem here.
0 kilobytes.
Oh god, this live stream is gonna end terribly.
Don't say that yet, but it is a possibility. All right, I'm gonna do.
You use this more often than I.
I'm gonna sudo it, even though I'm already the root user, because sometimes you just The next, I'm gonna turn it off and on next.
How do I stop the script once it's running? I can't, right? Is it?
It's unstoppable.
It's unstoppable, yeah. Oh wait, I did capture something. Hey, okay, so it's working on my. Wait, it's working on my end? Did I fix the Windows issue?
Wait, so this is broken, but you have it working on Windows.
Yeah, no, it's fixed.
Okay.
Easy.
All right, maybe we should switch over. Maybe we should switch over to your screen, and you should
show
me the working result.
No. Don't.
No, that's okay. It's okay. Trust me, the view is probably much better than my screen.
Well, first of all, it's kind of working, but not really. Packet size limited during capture. Yeah, something is going on. I can't really. I have a PCAP file, but it's like all broken.
I'm gonna try unplugging it. At least it recognized that I unplugged it.
Maybe just didn't receive any packets.
The baud rate is already baked into this, right? 21.
That what you see
92600. Yeah. So I shouldn't change that, right?
Yeah.
Cool.
Keep it as it is.
Serial connected. I'm not seeing anything tremendously different though. Usually, does it show any information as it's coming in at all? Yeah, all these files are 0 kilobytes.
Why did it work for me for like a second and then it stopped?
Well, I'm curious as to why an Arduino IDE. Oh wait, no. I want to make sure I didn't have the serial monitor still open because that would be stupid.
Live capturing using Wireshark. Okay.
Serial begin baud rate.
Yeah.
So the baud rate's defined up here. What if I change it? I just want to see. Maybe I'm going to reflash it with a slower baud rate, just because I can, and then I'm going to view it in the serial monitor and see what the difference is. Actually, so that way I can at least check things out on Arduino and see what it looks like, and make sure that I am getting something.
That's a good idea.
Thanks. I just had
115200. That's safe to use. I'm gonna try the same thing on my end.
Cool. Just gotta flash this thing all over again, which fortunately happens a lot faster than the ESP32 I think it's actually done. Yeah, done. Okay, cool. So now I'm gonna do the serial monitor. What can we see? Oh, a bunch of question marks. More question marks.
Let me see what I get. I don't get question marks. I get like empty boxes.
Oh, cool. Well, that's nice. Still useless, but nice. I'm gonna try now with these new fresh question marks and things. There's the port 11.
Actually, I'm gonna try to run this as an administrator as well.
Serial
So maybe
connected.
that's my problem.
Yep, and I've also got 0 kilobytes on this as well. Stefan, explain yourself.
I don't know. This is because you're using a Mac. So when was the last time you used this?
Oh, hey, wait a minute. I just pressed the refresh button many times, and it says stream started, and it just opened Wireshark. Have you tried hitting it, Stefan? Because that was the second thing I was going to try, but I figured it was stupid. Oh my god, it worked! Okay, just hit it. Stefan, have you tried hitting it?
What do you mean hit with hitting it?
I'm sorry. I came from a different background as you. I understand you're a computer science, but I also did a lot of electrical engineering and just engineering in general. The second thing you should try is just hitting it. So it turns out that the piece of code you were missing wasn't a piece of code at all. It was physically striking the device, because now I'm getting beacon frames.
Yeah, it's not working for me.
Hey,
but
have
hey,
you tried hitting it? Oh no, you're
what do you
hitting
mean
it
with
now.
hitting
Okay.
it?
No, you just mash the reset button like 15 times.
Oh, right. That could be.
And then it's done. Yeah. So okay. So for everyone who doubted us, we're now getting packets from the ESP32, and I'm going to take a look at one of them. Actually, let me just open it up.
Nice, and you get the live
what can we
output and
actually see?
everything.
So we can see the interface is recorded on, arrival time, shift time for the packet. We can see it's a beacon frame.
That's the same issue I have. Packet size limited during capture.
So it is getting something, but it looks like there's a lot that's actually being truncated here. And if yeah, it looks like there's not much. So I can still see the types of packets. Whoa, where did I go?
Yeah, this is
there we go.
Transmission issues or something. It's probably
Probe
with
requests.
all of the. It's probably with all of the packets. That's what I have seen on my end.
Interesting.
Oh yeah, I have.
Okay.
Yeah. Mine looks like similar. I have beacon. Beacon frames mostly. All packet size limited during capture.
Yeah, so I can see data, I can see beacon frames, but curiously, I can't see the source or the destination of any of the packets. So we're coming right up on the end of our time for today. But as you can see, we've taken a wireless microcontroller and got it to at least start sniffing, even if it hasn't given us all the information. But I'm sure with a little bit of tweaking, we could not only get this working on Windows, but probably figure out exactly what's going on with the source and destination reading. But still, encouraging progress. What we're doing now is we're actually taking this little microcontroller. Over serial, we're recording this to a file on, well, in this case, my root directory, but just a file on the computer. Then we're opening it up and watching it live in Wireshark. So once we get this source and destination problem sorted out, we can at the very least see where these beacon frames are coming from and start learning more information about the networks that they're representing. But for now, it's just a good sign of life to be able to see that, hey, we can actually capture some stuff, even if we can't see all the information, because it looks like it's being a bit truncated.
I swear this worked. Once upon a time, it worked. Probably 3 years ago.
I did a video on this not even that long ago, so I know it works too. But that's the value of doing the live stream. We get to do bug fixes, and sometimes the bugs are so big we can't quite totally fix them. But either way, you guys can see a little bit of the capability that these chips have. Instead of using a wireless network adapter, which can cost a good amount of money, you can still get into the basics of this using scripts like Stefan's Arduino PCAP library on a good day. and other sorts of ways of just taking advantage of the sniffing capabilities of these tools. Because even if you have the ESP8266, you can still do a lot of the same analysis and be able to determine when maybe a specific device is here. So we'll keep you up to date on this, because the version 3 of the D-Author, which is designed for the ESP8266, can do some really interesting sniffing, like being able to tell when a device is responding to a fake network it's creating, or just searching the area for a network to connect to that it's connected to in the past. So the signals intelligence capability of these little chips is really cool, although as you can see, the development does take some work.
Yeah, I hope we will sometime get back to this with a working version. Shouldn't be too hard. It's just more of a time issue on my end.
Of course. And if we can capture a handshake on this, as I really want to find out if we can do, I will be extremely impressed. So stay tuned for the sequel to this live stream. Lots of cool stuff you can do on the ESP32. And yeah, altogether, I'm just happy that we got this recording to Wireshark at all. It's a pretty big feat to be able to take the packets that are being received by this, send it over serial, save it, and then have it be in the correct format for Wireshark to be able to interpret it. So I still think it's really cool.
Then I'm glad we got something working at least.
Cool. All right. Well, that's going to do it for this episode of Hacking with Friends. I want to thank Stefan again for coming on and showing us how these little microcontrollers can do things that no one thought was possible. And I also want to thank Varonis for sponsoring these live streams and keeping them going. If you want to subscribe to these and see when we go live, you can go to the SecurityFWD YouTube channel. Make sure to subscribe, and soon we should have even more resources. So if you like this stream, make sure to retweet it, share it, look for the saved stream. As soon as we're done streaming, you'll be able to go back and watch it whenever you want. And yeah, share it with anyone you think would be interested, because we love doing these. We love hanging out with our friends and hacking on these devices and showing you guys what's out there. So yeah, just let us know. If you have any ideas for upcoming episodes, you can always tell me about it on Twitter at Kody Kinsey, but I cannot help you hack your girlfriend's phone. I think that's going to be it. So thank you, Stefan. We'll see you next time.
Yeah. Thanks for having me, and yeah, see you soon.
Bye.
Bye-bye.